Okay, so let's have another example of shear and moment equations and diagrams. And again, although we will use the equations, from end to end na lang ng segment, ng bawat segment ang gagamitin natin for the diagrams. So this is our sample problem number 4. We have here a cantilever beam with this fixed end at A, then free end sa C. Our load system or load diagram involves a uniformly distributed load with magnitude of 5 kilonewtons per meter and a concentrated load at C. And these are the distances between points for the segment. And again, we will compute for the reactions first. So I will temporarily remove the fixed support at A and replace with the reactions. So kapag fixed support, ang reactions nito involve X and Y components and a couple. So you need to review how you will compute for the reactions if there is a fixed support. So be very careful with the signs or the directions. Like for this one, ang resisting moment mo or yung couple which will resist the moments of all of your loads about A, ang lumabas ay counterclockwise na 180 kilonewton meter. And of course for RA, Y, it is upward 40. So it will just be the summation of all the vertical loads. In this case, you have 5 by 4, you have 20 downward, then another 20 downward for a total of 40 downward. So i-resist nitong 40 upward sa A. And since there are no horizontal loads here, RAX is 0. So we have two segments, AB and BC. So we will start with AB again. So imaginary cutting plane, measure it from A, and then I remove again the right side. So this is now the free body diagram of AB, and of course we need to get the equivalent single force of this rectangular load. So meron na tayong similar problem niyan sa previous samples natin. Kasi ganun ang kailangan gawin talaga if there is a distributed load, whether uniform yan or varying. Para madali nating ma-add or subtract sa iba pang vertical forces na nasakop ng distance x. So again, to solve for the equivalent single force of this, so the magnitude na 5 is multiplied by the distance x. And also its location, which is x over 2, or midway lang yan nitong distance x kung saan ito naka-apply. So for the shear equation, we will sum up all the vertical forces to the left of the imaginary cutting plane. So we have 40 minus 5x. So diniretso ko na dito kasi I'm sure naman na alam nyo na kung paano ang ginagawa kapag nagsasum up ng vertical forces. So we just have RAY minus 5x. So diniretso ko na yung RAY as 40. So that this will be the shear equation for segment AB. And for the moment equation, yung 40, may moment arm na x. Yung 5x, may moment arm na x over 2. Hanggang dito. So you just sum up their moments. So we have 40x in clockwise direction, positive. 5x counterclockwise with moment arm of x over 2. So bakit may 180 tayo dito? Kasi dito sa segment, dito sa distance x, nasakop mo yung couple, which is also a moment na reaction mo dito sa A. And since it is counterclockwise, then that is minus 180. So again, ang summation ng moments mo to the left of this imaginary cutting plane includes everything na nasa left or nasakop ng x dahil yung couple, which is a reaction at A, ay nasama nung distance x na ito, then kasama yan sa summation ng moment. So you have 40 by x minus 5x by x over 2 minus 180. Then we simplify, and this will be the moment equation for AB, which is 40x minus 2.5x squared minus 180. Then, for segment PC, we do the same. Then, I remove the right side, so that this will be the free body diagram. Okay, so this time, dahil nasakop nung x ay yung buo ng distributed load over AB, kaya yung equivalent single force ay 5 multiplied by 4 na. Again, with this imaginary cutting plane between B and C and distance x, nasakop na nito yung buong uniformly distributed load, kaya ang equivalent single force nito ay 5 kilonewtons per meter multiplied by 4, which is 20. And within this uniformly distributed load, kunin mo lang yung kalahati ng 4. So, that will be the location from A and from B. So, that will be 2 meters from either side. But of course, ang distance na kailangan mo ay hanggang dito. Kaya yung distance niyan ay x minus 2. So again, this is 2 meters from A, 2 meters from B, pero ang kailangan mo ay hanggang dito. So if this is 2 meters, then ang distance nito ay x minus 2. Then, for shear equation, we have 40 minus 20. Okay? And simplifying, you have V equals positive 20. And for the moment equation, so you have 40 minus 20 with this distance x, and of course, ito. Kasi ganun din, yung distance x na yan hanggang A, ay yung couple ay nasa A, kaya kasama yan sa moment equation. There. So you have 40 clockwise by x, 20 counterclockwise by x minus 2, and then minus 180. So simplifying this will give you this moment equation for BC, which is 20x minus 140. So itabulate na ulit natin yung ordinates. So again, from end to end na lang ng segment. So that for segment AB, we have x equals 0 and x equals 4. So using these equations, these are now the values of the shear and moment. And for segment BC, so ganun din. So by the way, ang limit natin for BC ay 4 to 7. Kasi yung BC natin is 3 meters ang distance. So with these equations, and values of x. So these are the shear and moment values. So let us now plot. Okay, so let us now plot the values of the shear and moment based on the equations. So again, from end to end na lang ng segment. So we draw a line parallel to the beam when x is 0 for segment AB. Nandun tayo sa point A. So, ang nakuha natin dyan ay positive 40. And then, when x is 4, for segment AB pa rin, we have positive 20. When x is 4, sa segment BC naman, we still have 20. And when x is 7, nasa BC na pa rin tayo, then we still have positive 20. So, when we connect this, we have to be very careful kasi pag tinignan natin, We will not have a horizontal line dito kasi from 40 tapos sa kabilang end 20. So, pwede mong pagbasihan itong load diagram. Dahil ito ay uniformly distributed load, ito ay horizontal line with 0 degree, kaya pagbaba mo sa shear, 1 degree yan. At kapag 1 degree ang line, straight line pa rin yan, pero naka-incline. Pwedeng incline upward to the right, pwedeng incline downward to the right. So, in this case, if you connect these two, it shows us that it is inclined downward to the right. So, a straight line. And for this, dahil wala kang load dito, if you connect these two, obviously you will have a horizontal line. And for the moment diagram, when x is 0, we have negative 180. So, dahil anticipated ko na yung values ng moment, in-adjust ko na itong distance ng ating line para sa moment diagram. So, nilapit ko na ng konti dito. So, again, when x is 0, the moment is negative 180. So, you can also observe na this happens kasi may fixed support ka dyan at meron ka na agad dito na moment or couple. Unlike nung simply supported beam na kung mapapansin ninyo, when x is 0, na kung saan merong hinge, 0 ang moment. Pero dito, kahit may fixed support ka dyan, na nag-start ka sa moment dito, kailangan mag-close pa rin yan sa 0. So, when x is 4, for segment AB, so we have negative 60. And when x is 4 sa segment BC, we still have negative 60. And when x is 7 for segment BC, we have 0. Then, we will connect these two at saka yung negative 60 at 0. So again, you have to be very careful. Kagaya nito. So, ito, 1 degree. Kaya pagbaba dito, second degree na yan. At kapag second degree, carved line na ito. And ano dapat ang concavity nito? Is it concave upward or downward? So, tingnan mo yung kung anong nangyari doon sa shear diagram. So, dahil yung shear values mo between A and B ay decreasing, kasi from 40, gradually decreasing to 20. So, based sa guideline, it is concave downward for the moment diagram. So that when you connect this and this, we have this curved line. So, curved line ito, which is concave downward. And for this segment, BC, dahil alam mo na this is 0 degree, dapat 1 degree dyan. So, if you connect negative 60 and 0, you have a straight line or a 1 degree line there. And this is now your load diagram. This is the shear diagram. And the maximum shear is 40. And for the moment diagram, maximum is 180. So again, kung kahit negative yan, if it has the greatest value, it is still the maximum moment. Kasi you will get the absolute value.